Pojolovet, Salam, and welcome to part 2 of our language tutorial, where you will learn to translate more complex chemical formulas. We've already learned that chemical formulas use subscripts written after chemical symbols to show how many atoms are present in a molecule of a substance. We also learned that coefficients, numbers written in front of a chemical formula, tell how many molecules of a substance are present. But proceed with caution, because chemical formulas can get tricky. Element symbols may appear more than once in a formula, and some formulas contain parentheses. Take a look at this molecule. Think the formula is C2H6O? Could actually be written more than one way. Sometimes formulas are written to show the arrangement of atoms in a molecule. Here you see CH3 bonded to CH2 and bonded to an OH branch. Sometimes formulas are written to show arrangement. This chemical formula contains a subscript following the parentheses. What do you think that means about the molecule? Well, parentheses can be used to show repeating branches of atoms in a molecule. The subscript behind the parentheses tells us there are two branches in the molecule that each contain an oxygen atom and a hydrogen atom. Get ready! It's time to play Translate That Substance. When you're given a chemical formula, tell how many atoms of each element are present. Use your periodic table and the chemical symbols to find the elements present in vinegar. Watch out because some element symbols are written more than once. How many atoms of carbon are in one molecule? How about hydrogen? How many atoms of oxygen? If you said 2, 4, and 2, you're correct. How many atoms are found in a molecule of ammonium phosphate, a substance found in fertilizer? How many nitrogen atoms? Hydrogen atoms? Phosphorus atoms? And oxygen atoms? If you said 3 nitrogen atoms, 12 hydrogen atoms, 1 phosphorus atom, and 4 oxygen atoms, you're right. Let's break down why. One strategy to help you visualize atoms in a chemical formula with parentheses is to draw out the repeating branches. The subscript 3 after the parentheses tells us that there are 3 branches that each contain NH4. Just a note, this is not exactly how the atoms bond in this substance. This is just for us to visualize how many atoms are in the molecule. Another strategy is to multiply the subscript outside the parentheses by everything that's inside the parentheses. Inside the parentheses we have 1 atom of nitrogen. Multiplied by 3, this gives us 3 total atoms of nitrogen. Do the same for the hydrogen, and you'll find that the 3 times 4 hydrogens equals 12 total atoms of hydrogen. Get ready, time for round 2. Translate that substance. When you're given a chemical formula now with a coefficient, tell how many atoms of each element are present in total. Use your periodic table and the chemical symbols to find the atoms present in 5 molecules of vinegar. How many atoms of carbon? How many atoms of hydrogen? How many atoms of oxygen? All right, now this one added an extra challenge. We not only have the element symbol written more than once, but we also have a coefficient. So because the coefficient is 5, you have to multiply everything in the formula by 5. So to get the total number of carbon atoms, we have 5 times 2, which will equal 10. Total number of hydrogen, we're going to have 5 times 4, which equals 20. And the total number of oxygen atoms would be 5 times 2, which would equal 10. Great job. Try another. How many atoms are going to be present in 2 molecules of ammonium phosphate? How about nitrogen? Hydrogen atoms. Phosphorus atoms. And finally, oxygen atoms. All right, so again, this is a challenge because there are parentheses and a coefficient as well. So we see in just one molecule we had 3 atoms of nitrogen, but now we have to multiply it times our coefficient. So 2 times 3 equals 6 total atoms of nitrogen. For hydrogen, remember we had 4 in the parentheses, but there's a subscript outside it. We had 12 atoms of hydrogen in just one molecule. Now with 2 as our coefficient, we have to multiply that. So 2 times 12 equals 24. For phosphorus, we had 1 molecule, 1 atom in each molecule. 2 molecules would mean 2 atoms of phosphorus. And finally, oxygen, 2 times the 4 atoms of oxygen in each molecule would equal 8 total atoms. Bravo. Buen trabajo. Now it's time for some practice on your own. Match the molecule with its chemical formula. How many atoms of oxygen are in a molecule of aluminum chlorohydrate? And finally, how many nitrogen atoms are in 3 molecules of caffeine? There's methanol. It's CH3OH. Now you have the basics of speaking chemical formula.